Hello friends, welcome to my channel Emulation Nerd, and today we will be discussing about the data engineering concept of the conceptual design. And in this video we will be discussing several concepts of attributes, entities, relationships and cardinalities, etc. And at the very last of the video we will be designing a very interesting problem called the online bookstore that works in the similar way as the Amazon bookstore. So designing concept will help you out in various interviews for the SDE tools in the tech giants for the system design, and hence it can be proved very useful if you utilize it better. So before starting the video I will clearly describe that if anything you didn't understood, please pause the video and re-listen it again in order to clarify the concepts all at once. So let's begin. So the analysis and design of an OLTP system are analysis of requirements, conceptual design, logical design and physical design. The output of an entity relationship model should answer the following. Let me write it down for you. So the output of an entity relationship model should answer what are the entities and relationships in the enterprise. Secondly, it should answer what information about these entities and relationships should be stored in the database. What information about. And lastly, it should answer what are the integrity constraints or business rules that hold. What are the so, so these are the following questions that every entity relationship model should answer. And moving forward, we should describe what a logical design is. So the logical design is an extra step where diagram obtained from the conceptual design will be mapped into a normalized relational data model. Hope you now you got clear understanding of what a logical design is. And considering about the physical design, so physical design is the final step which consists of SQL programming in order to create, populate and query a relational database. So basically there are three types of design. The first being the conceptual design, second being the logical design, and third being the physical design. So let me repeat it once more. So the logical design is an extra step where the diagram obtained or the entity relationship diagram obtained from the conceptual design will be mapped into a normalized relational data model. And physical design is the final step which consists of SQL programming in order to create, populate and query relational database. Now moving towards the concepts of conceptual design or designing a database. First being the entity. So an entity represents an object or thing of real world and is distinguished from others according to the characteristics. So an entity is a collection of similar entities. For example, you can consider a set of all employees in which each employee is an entity, and it or set of all the employees can also be considered as an entity. So the whole set or subset or superset of employees, all of them are entities. And entity is represented by rectangle. Let me write it down here for you so that it can be helpful in further discussions. Rectangles. And further discussing about the properties, there is another property called attributes. So attributes are the properties of an entity. If you can consider in a real world object, every object has certain characteristics. So in order to represent those characteristics in an entity in our database model, so attributes are being used, and each attribute is represented by ellipses. And every ellipse represents one attribute and is directly connected to its entity. Another characteristic or another feature, or let's discuss about key as well. So key is an attribute or collection of attributes that uniquely identifies an entity among an entity set. An attribute that is a key is underlined. For example, you can consider the roll number of a student makes him or her identical or identify among the students. And a super key is a set of attributes, one or more, that collectively identifies an entity in an entity set. So the key consists of two types: super key and primary key. Now talking about the primary key, a primary key is one of the candidate keys chosen by the database designer to uniquely identify the entity set. So the identifier key should be underlined. All these concepts will be required while designing the conceptual design of the Amazon bookstore, which we are going to design at the very last of this video. So another concept is of relationship. So a relationship is an association among two or more entities. For example, consider an employee working for a particular department. So the employee works for a department in which the employee and department are two entities that we can consider of, and the relationship between them is work. So the employee works for a department, or the department gets work from the employee. So a relationship is a collection of similar relationships, or we can say a relationship set is a collection of similar relationships and is represented by a rhombus. Another concept is stat of cardinality. So cardinality specifies how many instances of an entity relate to one instance of another entity. Let me repeat this for you again. A cardinality specifies how many instances of an entity relate to one instance of another entity. And there are four types of binary cardinality: 1, 2, 1, 1 to many, many to 1, and many to explaining the cardinality, we can just explain it by giving an example. So consider an example. According to different business rules, two entities can be related in different ways. On the other hand, employee, considering the example we gave of an employee working for a department, so employee can work in many departments and many employees can work in a department, so it is a many to many relationship model. On the other hand, an employee can work in only one department and the department is composed of many employees, so it is a many to one relationship. So hope I am clear to you regarding the cardinality, and the degree of relationship indicates the number of entities that a relationship associates. Now let me diagrammatically explain to you what are binary, ternary and unary relationships. So let me just draw something. Suppose we have an entity. Consider this entity and it is connected or it is related to itself. So in this situation it is a unary relation, and considering for a binary relation. Suppose there are two entities. And they both are related to each other in this way. So it is a binary relation, and for the ternary relation we can have three entities and all of them are related to each other with a single relationship. So the first being the unary relation, second being the binary, and the third being the ternary relationship. Now let's discuss it. Let me just write it down. Now let's discuss about the entity schema. So an entity schema is the definition of a structure of an entity. So definition of the structure of entity, and in this there is a concept of redundancy. So the redundancy corresponds to storage of the same data several times in different places. As we have seen, cardinality indicates a number of entities with which a given entity may be related. In case of consistency, it happens when redundant data are not equal to each other. The primary key uniquely identifies each entity. The intention of a database is a set of definitions of the data structures for the particular database, also called a database schema. Now let's look towards the instance. What we call an instance corresponds to the actual content of the database, or we can say the data at a particular instant. The data and the database instance tend to change with time. So I think by now I pretty much discussed every concept of the database. If I missed out something, I will discuss while designing the bookstore. So well, now it's time to know the steps in designing an entity relationship program from the user's requirement. So let me just designing steps. So the first place we need to identify entity types. Entity type. Secondly, Then we then the second step, we then need to identify the relationships between the entities. Thirdly, we need to identify and associate attributes with entity and relationship types. And finally, finally, the fourth one. And fourthly, we need to determine attribute domains. So what an attribute domain is, we describe what an attribute is the characteristics of each entity, and to represent the characteristics of each entity we need to have some data type of that entity. Consider we are having the characteristic of the name of a student, and we need to determine the data type of the name. So the name data type would be string. So by domain we refer to the data type of the attributes. Then we need to determine primary key attributes for the entity, and determine primary key attributes for the entity. And lastly, associate the cardinality radius with the relationship types. Yeah, let me first show, before designing the database, let me first show you what a cardinality radius looks like, or a cardinality number looks like. Let's just start from, we will be considering the example of employee and department many to one relationship that we described before. So consider an entity, employee, and another entity as department. And as we discussed before, both of them are being related to each other by relationship known as work. So let's represent it with a rhombus and associated with each other. Now representing the attributes, so it has an attribute called name, and it will be represented by an ellipse, and primary key should be ID, and it is also an attribute, and the primary key should be underlined. So it should be underlined, and they are directly related to the employer. Yeah. And the department will have one attribute name as the ID of the department. To be very make it clear, I will write ID underscore department, so you might not get confused between the ID of the employee and ID of the department. So it is a primary key and it should be underlined, and another primary key and another attribute might be department name, department underscore. As it is not a primary key, we need not underline. So they both of them are also connected to the departments. And as we discussed in the example that many employees work in a single department. So on the left side of the work, many departments, let us consider M employees work for a single department. So there is a relationship coming to work from M employees and one relationship going to the department. So the cardinality left of employee is M and the cardinality of the department is 1. I hope everything up till now is clear to you, and now I am going to design the Amazon bookstore or the online bookstore which we described before. That is a pretty interesting stuff. So basically this is the description of the design that we are going to implement. So we require to develop an information system that supports some of the services involved in an online bookstore. Example, Amazon.com. The bookstore has registered customers in order to sell books. It also contains publishers information as and the customer can place the book it desires to buy in a shopping basket. The first constant being a customer has an email, name, phone and address. A book has an ISBN, year, title and price. Publisher has a name, address, phone and URL and publishes several books, but one book can be published by one publisher. And author has a name and address and can write several books. Books can be written by only one author and they are stored on many warehouses, and one warehouse has many books. A customer can have several shopping baskets. Each shopping basket belongs to one customer, where each shopping basket can contain several books. So this is the problem description. Let's just dive in by designing. So in the very first step of the design, we need to identify the entities. So the first entity being the customer. Second entity being the shopping basket. Third entity that we were given is a book. Yeah. The fourth entity, I think this will be the last one. Author. Just verify once. Yeah, author. I think we are done. Let me just verify it again. So well, I missed one entity named as warehouse. There is an entity named many warehouses and warehouses many books. So we just need to define another entity called warehouse. So after defining the entities, we need to find the relationship between the entities. So a customer is related to the shopping basket that a customer has a shopping basket. So there is a relationship named as and a shopping basket has books. So shopping basket house. And a book is written by author or author writes book. So and a warehouse stores book. So book being the common between the relationships, that's why I represented it in the middle, so it will be easier to design. So now I think I have described all the relationships, and after describing the relationships, now we need to identify the attributes as well as identify the primary keys. So let's begin with the customer. So customer has an email, customer email. So customer, each email should be unique. So email might be the primary key. Let's describe this one. Email can be a primary key, so let's keep it as a primary key. And email name, phone, and address. So I think we are done with the customer. Now let's move towards the shopping basket. So there's nothing given about the shopping basket, so a shopping basket can be identified by just its ID, or we can just represent it by basket ID. Basket underscore so every basket ID will be different for every basket, and it can be considered as an attribute of the basket ID. Now moving towards the book, I think I have missed one entity as well. There is an entity named publisher, so let's just define that entity as well. Just and the publisher publishes, so the relationship for yeah. Now let's start defining the attributes of book. A book has an ISBN. ISBN can be an identifier for its book. I mean the primary key. Let this be the primary key and the line of ISBN year. YR. Title. And price. It's really tricky to write on the mouse pad. Price. Now let's describe the attributes for warehouse. There's nothing given for the warehouse, so we can just put the primary key as warehouse underscore ID. And for the author, the attributes will be name, address, yeah, for the author, name, address, yeah. And we can since both the attributes can't be the primary, we need to identify with the author ID. AUTH and for the publisher, similarly, since there is no space, you can just write down the attribute that the way we have written in other entities. And let's move on to mentioning the cardinality. So one customer can have many shopping baskets. One customer can have many shopping baskets, and many shopping baskets can have many books. Yeah. Move on to biological reasoning. We can express this. And one publisher can write many books. So one publisher can write many books, and many books can be written by one author. Book, and many books can be stored in many warehouses. Yeah. So let me check the business constraints that are given to us. Shopping basket, investing, shopping baskets. Yeah, I think we are pretty much good with the design of the database of the online bookstore that is given to us. So I think we came to an end of the conceptual design discussion, and hope everything is clear to you. If anything it happens that I might have missed out, or if there is any confusion, please comment down in the description box below, and I will surely make a separate video regarding that. As well as if anything is unclear to you what explained in this video, please pause the video and listen it again or rewind it, so that everything will be crystal clear to you. So I hope you liked this video, and please do like, comment, share and subscribe, as well as tap the bell icon so that you don't miss the next video, or you will get the earliest notification to view my next video. My next video will be going to convert this conceptual design to the logical design. That will be a normalized form of the ER diagram. So this is called the ER diagram. Hope to see you in the next video then. Goodbye.